Okay, so in section 10.3, we're going to change to area now. So for 10.3, we're going to talk about the area of all sorts of figures. And then in 10.4, just like we did with perimeter, we switched to from all sorts of figures to just circles. Same thing. We're going to do 10.3, all sorts of figures. And then 10.4 is going to be all about circles. Okay, so what is area? Area is the amount of two-dimensional space an object takes up in square units. So if you wanted to put carpet down in one of your bedrooms, that would be the area. Okay, so what area formulas do you remember that you've definitely seen and used before? You know we're going to go over those, but you know we're also going to take it up a notch and bring back in stuff that we've already learned this year as well. So our area formulas, the area of a triangle is 1/2 base times height. And again, keep in mind the height of a triangle is always perpendicular. A rectangle is length times width. A square is side squared. Again, all four sides of a square are congruent. A parallelogram is base times height. And again, notice that this piece is the piece that is the height. Okay, it is not one of the sides that I'm doing in squiggly. That is not the height of that parallelogram. Again, height is always perpendicular. And a trapezoid is 1/2 the base 1 plus base 2 times the height. And again, notice that this height is perpendicular. It is not one of the sides, again, that I'm putting the squigglies through on the outside. Those are not your heights there. Okay, so again, what we'll do is we'll do just review of the basic figures first, and then again, we'll amp it up a notch. So we want to find the area of each figure. So part A is a square. So again, the area of a square is side squared. Since one of my sides is 8.5, we'll do 8.5 squared, which will give me an answer of 72.25. Again, if you said 8.5 times 8.5, that's the same thing as 8.5 squared, so it doesn't matter there. For part B, that's a rectangle, and the area of a rectangle is length times width. So in this case, we're going to do 10.5 times 3.7. Again, it doesn't matter with a rectangle which one you call the length and which one you call the width, because again, multiplication is commutative. The order does not matter. When you multiply there, you should get an answer of 38.85. For part C is a trapezoid. So again, the area of a trapezoid is 1/2 of the base 1 plus base 2 times the height. Okay, so base 1 is 9, base 2 is 20. Hey, again, does it matter which one you call base 1 and base 2? Nope. Okay, and height is always perpendicular, and since this side is perpendicular to the base, that means that 15 is going to be the height here. So I'm going to have 1/2 of 9 plus 20 times 15. Okay, again, you can stick that all into the calculator at once. When you do that, you should get an answer of 217.5. D, that's our triangle, and the area of a triangle is 1/2 the base times the height. Our base here is 15, and again, height is always perpendicular, so since that arrow is pointing to that line that is perpendicular, our height is going to be 21.3 here. So we're going to do 1/2 of 15 times 21.3. Again, you can chuck that all into the calculator at one time. When you do that, this one should come out to 159.75. Okay, and lastly, for part E here, again, part E is going to be a parallelogram. And again, the area of a parallelogram is base times height. So again, 8 is going to be our base. And again, height always has to be perpendicular. So this line, even though that should have a right angle marker there, that is going to be your height. This is the side. The side does not come into play in this formula. So you're going to have area equals 8 times 4, and 8 times 4 is 32. Okay, so now we'll start making it just a little bit harder here. So for number 2, a patio is to be made in the shape of an isosceles triangle as shown. Why would the calculation area equals 1/2 of 22 times 16 not result in the correct area of the triangle? Okay, so again, the area of a triangle is 1/2 the base times the height. Okay, now 16 is absolutely the base, but the height, again, is not 22. Height always has to be perpendicular. So the height would technically be that gray line, that gray dotted line that I just drew down the center. Okay, so the height of the triangle is not 22. Okay, so now for part B, we want to actually determine the area of the patio to the nearest square foot, which means we need to find the height. So now, again, if this is isosceles, what I'm going to do, change my color here so you can see it a little bit better. I am going to concentrate on one side of that triangle. Okay, I can find that height x by using the Pythagorean theorem. Again, since this is an isosceles triangle, that means that my base is getting bisected, which means each piece here will be 8 units long. So now if I'm concentrating on just that burgundy color triangle on the left, that's a right triangle. I am missing one side of that right triangle now, which means we can use the Pythagorean theorem. So first thing I'm going to do is find the height by using the Pythagorean theorem. So a squared plus b squared equals c squared. Again, the only thing that matters is what goes in for c. Again, I drew that arrow directly opposite your right angle. The hypotenuse of that triangle is 22. So 22 has to go in for c. It doesn't matter how you plug in for a and b. So I'll say x squared plus 8 squared, again, equals 22 squared. Okay, 8 squared is 64. 22 squared is 484. Next step to solve here, we'll subtract 64 from both sides. Bring this up over here. That's going to leave me with x squared equals 420. The opposite of squaring something is taking the square root. And when you take the square root of 420, it's going to come out, I'll do to the nearest tenth, to 20.5. Okay, so now 20.5 is the height. So now finally I can find the area of that triangle. Again, area is 1/2 the base times the height. Again, the entire base is that 16. So we're going to have 1/2 of 16 times 20.5. Once again, you can chuck that all into the calculator at the same time. And when you do that, you should get an answer of 164. And for the last part of that question, it says if the patio is to be covered by stone, which costs $12.25 per square foot, what will the total cost of the patio be? So again, to do that, we'll take the area of the patio, which we just found above, which is 164, and multiply it by the cost of each square foot, which is $12.25. And when you do that, you should get $2,009. So it'll cost you $2,009 to cover that patio. So again, we want to find the area of the triangle ABC and round to the nearest tenth. So again, right off the bat, this seems extremely straightforward. Area is 1/2 the base times the height. So my height here is AB, which is 8, but then, I don't have AC. Hey, now I also don't have BC, so I'm not just missing one side of this right triangle, I am missing 2 sides of that right triangle, which means that I cannot use the Pythagorean theorem here. Okay, but what can I do? I can use trig. I can use SOHCAHTOA to find the length of AC. So with relation to 35, that 8 is the side directly opposite, and x is right next to or adjacent. So the trig function that deals with the adjacent and the opposite side at the same time is the tangent. So we're going to do the tangent of 35 equals the side opposite, which is 8, over my side adjacent, which is x. Again, I'll chuck the tangent of 35 over 1, and now we're cross multiplying to solve. So I'm going to have the tangent of 35, x times the tangent of 35, equals 8. To get the x by itself, right now you're multiplying x by the tangent of 35. The opposite of multiplying by the tangent of 35 is to divide by the tangent of 35. Those will cancel. So again, in the calculator, you're doing 8 divided by the tangent of 35. Once again, just please make sure that your calculator, if it's one of the Texas Instruments one, is in degree mode, or again, you're going to get a wrong answer. When you do that, it should come out, I'll do 2 spots after the decimal, it should come out to 11.43. Okay, so now I have enough information to solve for the area here. Area is going to be 1/2. We just found the base is 11.43 and our height is 8. So again, we can chuck that all into the calculator and just hit enter. And when you do that, you should get an answer of 45.7. Okay, so the next thing that we need to do is find the area of triangle ABC given these coordinates. So A is 3, 2, which is going to be here. B is going to be 7, negative 1. 1, 2, 3, 4, 5, 6, 7, negative 1. And C is 6, 1, 2, 3, 4, 5. So there's C. So I'll connect my dots. And there we go. Okay, so again, seems like this should be easy enough. I have 1/2 the base times the height for my area. But here's the problem. I can't count any boxes here. I don't know the length of the side. I don't know what's perpendicular. So here, the easiest thing to probably do is to enclose this figure into a rectangle. And then you're going to see you'll end up having right triangles that are going to be easy to end up subtracting out. So what do I mean by enclose that in a rectangle? There is my rectangle. Okay, so what I'm going to do is I'm going to find the area of that purple rectangle. Once I find that purple rectangle, I'm then going to start subtracting out these blue small triangles. So I'm going to subtract out the area of triangle 1. I'm going to subtract out the area of triangle 2. It's going to be really hard for me to trace. And I'm going to subtract out the area of this third triangle over here. So if I take that purple rectangle and get rid of those 3 triangles, it's going to leave me with that burgundy triangle again in the middle. Okay, so the area of the rectangle. Again, area of a rectangle is length times width, and now I can easily count the length and the width of that rectangle. The length, 1, 2, 3, 4. And the width is 1, 2, 3, 4, 5, 6. And 4 times 6 is 24. So 24 is that entire rectangle. So now let's find our 3 triangles, and then we'll subtract from that 24. So the area of triangle 1 is going to be 1/2 the base times the height. Please be careful when you're counting here. Again, just make sure 1 won't be so hard. 2, you have to make sure that you're doing the full length of the bottom there. But let's talk about 1 first. So 1 base and height. So the height is 1, 2, 3. And 1, 2, 3. It's 3 by 3. So that's going to be 1/2 of 3 times 3. 3 times 3 is 9, and 1/2 of 9 is going to be 4.5. So that's the area of triangle 1. The area of triangle 2. Hey, again, just be careful when you're counting here. Triangle 2 goes all the way across here. It doesn't stop right here. Okay, so the area of 2, again, is going to be 1/2 the base times the height. So the base is 1, 2, 3. It is 4 units long. Again, pretty pleased with sugar on top. Be careful counting there. And then up, 1, 2, 3. And it's 3 units high. So we're going to have 1/2 of 4 times 3. 4 times 3 is 12, and 1/2 of 12 is 6. And our last one, the area of triangle 3 is again 1/2 our base times the height. This is another one that you really need to be careful with. The base or height, however you're looking at it, has to go all this entire side of that rectangle. So the entire side again is 1, 2, 3, 4, 5, 6. And the other piece is going to be 1 unit long. So we're going to have 1/2 of 6 times 1. 6 times 1 is 6, and 1/2 of 6 is 3. So now we can take our full rectangle of 24 and subtract out those 3 areas of the triangles that we just found. So we'll subtract out 4.5, we'll subtract out 6, and we'll subtract out 3. And when you do that, your final answer here is going to be 10.5. So the area of that original triangle is going to be 10.5. All right, so a composite figure is a figure that can be separated into 2 smaller figures. Or if you look at it the opposite way, you're putting 2 figures together to get the composite. To find the area of a composite figure, you can find the area of each smaller figure and then add them together. Okay, if you're trying to find the area of a shaded region, you're always going to take the area of the larger figure and subtract out the area of the smaller figure from it. So let's work on a composite figure first. Okay, so here's a figure. It looks like I have a rectangle on top of a trapezoid. Okay, so what we're going to do is, again, we're putting these together. So we're just going to take those 2 figures and add them together. So in other words, we're going to do the area of the rectangle plus the area of the trapezoid. Okay, now I'm going to put in the formulas for each one of those. The area of a rectangle is length times width. And to that, I'm going to add the area of my trapezoid, which is 1/2 of the base 1 plus base 2 times my height. And now from the picture, we'll just plug our information in. So for our rectangle, our length and our width are 12 and 23. So I'll have 12 times 23. Bring down the plus sign, bring down the 1/2. For my trapezoid is this figure on the top again here. So base 1 here is 15, and base 2, if that top figure is a rectangle and that piece is 23, that means that piece is going to be 23. So base 1 and base 2 are 15 plus 23, and now I need the height of that figure, and the height of that figure is this piece right here. Okay, well, they told me over here that from the entire top to the bottom of that figure, that's 18 units. And from over here, we know that the height of the rectangle is 12. So if I take 12 away from those 18 units, that's going to leave me with 6. So the height of that trapezoid is going to be 6. And now it's just a matter of plugging this into the calculator and simplifying. Just make sure that you're following order of operations. You have to do both sets of multiplication first before you can add the 2 areas together. In other words, the first thing I have to do is 12 times 23. 12 times 23 is going to give you an answer of 276. Okay, on the other side, half of 6 will give me 3. And when I add these 2 together, I'm going to get 38. Sorry, I'm doing this in my head. So 276. And you can plug this whole right-hand side into the calculator at one time if you want. Again, I'm doing it by hand here. So 3 times 38 is going to give you an answer of 114. So when I add those 2 together, 276 plus 114 is going to give you an answer of 390. So the area of that composite figure is 390. Okay, and now let's do a shaded region question. Okay, so again, shaded region is always the area of the larger figure minus the area of the smaller figure. Okay, so what 2 figures do I see here? A rectangle and a triangle. Which one's bigger? The rectangle. So this time around, we're going to do the area of the rectangle, and the area of the triangle is smaller, so we'll subtract out the area of the triangle. Again, basically, we're going to follow the same thing that we just did in the other problem. First thing I'm going to do is replace the areas that I'm looking for with their formulas. So the area of a rectangle is length times width. The area of a triangle is 1/2 the base times the height. And now we'll just go to our picture and figure out what we need to plug in. Base, or length and width, base and height, doesn't really matter what you call it, of that rectangle are 14 and 25. So I'll have 14 times 25 minus 1/2. The base of this triangle is this side, which is the opposite side of that 25 of that rectangle. So the base of your triangle is going to be 25. And again, height is perpendicular. So that piece is your height there of 11. So again, you have to do what's to the left and to the right of that subtraction sign before you actually subtract. You have to follow the order of operations. So 14 times 25 should give you an answer of 350. And on the right-hand side there, 1/2 of 25 times 11. Again, you can chuck that all into the calculator at one time. That's going to give you 137.5. Okay, and now we're just going to subtract 350 minus 137.5 should give you an answer of 21.5 as your answer. Okay, and that is it for this section.